education is not learning of facts. It's making mind to think. Welcome to Old School Electrical, where we simulate minds to think. So in the last class, we have discussed about battery and how it generates EMF. So in today's class, we are going to discuss about resistance and variation of resistance with temperature. We will start the class with Ohm's law. So what is voltage? Potential difference between two charged plate is called voltage. So how we generate voltage, how we produce voltage? Using battery. So in the previous class, we have discussed about a single cell. The single cell had two electrodes. One is the copper electrode, another one is the zinc electrode immersed in dilute sulfuric acid, which act as electrolyte. So due to chemical reaction taking place between the two electrodes and the electrolyte, charging takes place. The chemical energy charges the copper electrode to positive potential and charges the zinc plate to negative. So the work done in charging is stored inside the charged particle as stored energy, which is the electric potential. Now these two plates, positive plate and negative plate, are having certain electric potential. The difference in potential between these two plates is called potential difference. This potential difference is nothing but voltage. Okay. Now we are connecting a conductor. Between these two charged plates, we are connecting a copper conductor or say an aluminum conductor, anything. So if it is a copper conductor, what is the atomic number of copper? Atomic number of copper is 29. So how many electrons are there in copper atom? 29 electrons. So how will be the electronic configuration? In first orbit, we will be having 2 electrons. Maximum number of electrons that can be accommodated in an orbit is given by 2n square. So where n is the orbit number. So first orbit will have 2 electrons, second orbit will have 8 electrons, third orbit will have 18 electrons, and the last orbit, this is 10, 28, will have 1. The electrons in the last orbit is called valence electron. So there will be only one valence electron. This valence electron will be loosely bound to the nucleus and it will come out of the atom as free electrons. So each atom will contribute one free electron. So when the conductor is connected between these two electrodes, the positive electrode attracts the electrons. So the free electrons are attracted and it will move towards the positive plate. Once the free electrons moves, the copper atom becomes copper ions. So once this becomes positive, it will attract electrons from the negative plate. So electrons from the negative plate now started to move. And there will be continuous flow of electrons from this negative electrode to the positive electrode through the conductor. This rate of flow of electrons is called electric current. Now, when I increase the potential difference between these two, say I am applying more chemical energy, I am adding chemical such a way that it produces more chemical energy, what will happen? When there is more chemical energy, more potential difference will be created. Potential difference increases or voltage increases. When the potential difference increases, the rate of flow of electrons will be more. So the rate of flow of electrons or the current flowing through the conductor is proportional to the voltage applied across the conductor. Clear? So let V is the voltage applied across the conductor. V is the voltage applied across the conductor. It will be proportional to the current. So if you want to make it as an equation, what should be done? If you want to make it as equation, we have to add an proportionality constant. So I am adding R as proportionality constant. V equal to R into I. And this R is the constant which I have added to make it as an equation. So this R proportionality constant R is called resistance. So from this equation, if you want equation for resistance R, what will you do? If you want R, take this I to the other side. So I, when it goes to other side, it comes to denominator. So V by I. This is constant. So as per Ohm's law, at constant temperature, the voltage across the ends of the conductor is proportional to the current flowing through the conductor. Or in other words, we can say at constant temperature, the ratio between the voltage applied across the conductor and the current flowing through the conductor will remain constant, and it will be equal to resistance. Clear? So what is the unit for resistance? The resistance concept is devised by Ohm. So based on his name, unit for resistance is ohms. And this is the symbol used to denote ohms. Unit for resistance is ohms. Is it clear? So the resistance is 1 ohm. Resistance is 1 ohm when a voltage of 1 volt causes 1 ampere current to flow through it. So the resistance of this conductor is 1 ohm when a voltage of 1 volt causes 1 ampere current to flow through it. So when the potential difference is 1 volt, and because of that, if 1 ampere current flows through that, the resistance equal to 1 ohm. So it is voltage by current. 1 volt causes 1 ampere current to flow through that, then the resistance is unity. That means 1 ohms. Clear? What is the unit for resistance? Ohms. And this is the symbol for ohms. Now we need an equation to calculate the resistance. So when I increase, before that, how the resistance is created? So what is resistance? We have written that V equal to R into I, right? The voltage applied across the conductor is proportional to the current. The proportionality constant is R. So R equal to V by I. That is what we have written. V comes to denominator, so V by I. So we can say resistance is inversely proportional to the current. So resistance is inversely proportional to the current. So when resistance increases, what will happen to current? Relationship is inverse. When resistance increases, what will happen to current? Current decreases. When resistance increases, current decreases. So I can say resistance is the opposition afford to flow of current. Resistance is the, when resistance increases, current decreases. Inverse relationship. That means resistance is the opposition afford to the flow of current. Which one is giving this opposition? Current is flow of electrons. That is flowing from this negative plate to positive plate. So when the electrons moves from negative plate to positive plate through the conductor, the stationary atoms of the conductor gives opposition, because the electrons collides with the stationary atoms. The electrons collides with the stationary atoms. During the collision, it loses energy and it will be released in the form of heat. So as the moving electrons loses energy, the rate of flow of electrons decreases. What is current? Rate of flow of electrons. When the rate of flow of electrons decreases, that means there is reduction in the flow of current. So why the rate of flow of electrons decreases? Due to the presence of the stationary atoms, due to collision with the stationary atoms. Now you have to answer me another question. Say I am increasing the length of the conductor. I am increasing the length of the conductor. What will happen now? Resistance will increase or decrease. So if I increase the length of the conductor, the electrons traveling from negative plate to positive plate has to travel a long distance. So the electron has to travel a long distance to reach the positive plate. So the chance for collision is more. Number of collisions are more. That means current flowing per unit time or electrons flowing per unit time will be less. So when the length of the conductor increases, the electrons has to travel a long distance to reach the positive plate. So number of collisions increases and hence the rate of flow of electron decreases. That means current decreases. Current decreases means resistance increases. That is the meaning. So when I increase the length of the conductor, current decreases. So we can say resistance increases. So when length increases, resistance increases. So resistance is directly proportional to length. You got it? And resistance will also vary with the area of cross section of the conductor. Look at the diagram. Just for example, I have drawn the diagram. So in each cross section I have shown two atoms. Okay. So at a time, each atom will contribute one valence electron. So at a time, say 2 electrons are reaching the other end. 2 electrons are reaching the other end. Now I am doubling the area of cross section. What will happen? What will happen to resistance? Can you tell me? Think about it. The area of cross section is doubled. So instead of 2 electrons, now 4 electrons moves together. 4 electrons moves in parallel. So amount of electrons crossing a section of conductor in 1 second increases. Amount of electrons passing through a section of conductor in 1 second is the electric current. So when I increase the area of cross section, current increases. When current increases, that means resistance decreases. When area of cross section increases, resistance decreases. So resistance is inversely proportional to area of cross section. So combine these two. Resistance is directly proportional to the length, inversely proportional to area of cross section. So I can write resistance is proportional to length, inversely proportional to area of cross section. How to make it as an equation? Earlier V proportional to current. To make it as an equation, we have added an proportionality constant R. Here also we have to add an proportionality constant, and the proportionality constant added is rho. Rho is the proportionality constant. Okay, so resistance is rho L by A. So what is the formula to calculate resistance? R equal to rho L by A. Rho is the proportionality constant and it depends on nature of the material. For copper it will have one value, for aluminum it will have another value, and like that. And this rho is called specific resistance. And it is having the other name resistivity. Rho is called specific resistance or resistivity. It is the proportionality constant. Okay, so from here I want an equation for rho. What should be done? A is in the denominator. When you go to other side, it will come to the numerator, or it comes to the numerator A. This L, when it comes to other side, it will go to denominator. So this is the equation for rho. Rho equal to RA by L. I am writing this to find the unit for specific resistance or resistivity. So what will be the unit for specific resistance or resistivity? Rho equal to, what is the unit for resistance? R. Unit for resistance? Ohms. What is the unit for area of cross section? Meter square. Unit for length? Meter. So this meter and the square will cancel, leaving unit for specific resistance or resistivity as ohm meter. Unit for specific resistance or resistivity is ohm meter. Okay. So this rho equal to R. Rho equal to R if this area is 1 meter square and if the length is 1 meter. If the length is 1 meter and area is 1 meter square, the resistance will be equal to specific resistance. So in that way we can define specific resistance. So specific resistance is the resistance offered by 1 meter length of the conductor which is having area of cross section of 1 meter square. Specific resistance is the resistance offered by 1 meter length of the conductor when its cross sectional area is 1 meter square. Clear? In that way we can define specific resistance or resistivity. Is it clear? Yes. And there is one more term called conductance. Conductance denoted as G, and it is the reciprocal of resistance. Resistance is the opposition offered to the flow of current, and conductance is the easiness to permit current to flow through it. So R equal to rho L by A. So G is 1 by R. G is 1 by R. So 1 by rho L by A. What will be? A by rho L. And this 1 by rho, what is rho? Resistivity. And the reciprocal of resistivity can be called as conductivity. Reciprocal of resistivity is conductivity. So G equal to 1 by rho is conductivity, sigma A by L. Okay. So what is the unit for resistance? This unit for resistance is ohm. Conductance is the reciprocal of resistance. So unit for conductance is ohms spelled from other side, mho, M-H-O, mho. How will you represent ohm? Like this. So if you put it upside down, it denotes unit for conductance. Clear? Now we are going to discuss about the variation of resistance with respect to temperature. And earlier during our first lecture we have discussed about what is conductor and what is insulator. So what is conductor? Metals in which the valence electrons are loosely bound to the nucleus are called conductors, because those valence electron will come out of the atom as free electron. So metals which are having free electrons are called conductors, and materials which are not having free electrons are called insulators. That means the valence electrons are tightly bound to the nucleus. So if you take the case of an insulator, even if I connect an cell, there will not be current flow. What is the reason? Here we have atoms. but there is no free electrons. The valence electrons are tightly bound to the nucleus of the atom. So it is not coming out as free electron. So if we want to take the valence electron as free electron, we have to apply external energy to overcome the binding energy. So when I apply, you will understand this concept only when you listen to my first lecture. So when I apply an energy or thermal energy to overcome that binding energy, we can take the valence electron outside the orbit as free electron. So in the insulator, when I increase the temperature, what will happen? I am giving energy, I am giving thermal energy. So the valence electron will come out as free electron and it will start to conduct. That means current flows. There will be flow of current. Before I apply temperature at 0 degree centigrade, when the temperature is 0 degree, there is no conduction because there is no free electrons. So the positive charges cannot attract electrons. The positive plate is not having the energy to attract the electrons. When I give temperature, I am giving extra energy. So with that extra energy, the valence electrons comes out as free electron, which will be attracted by the positive plate, and there will be flow of current. Current flow is initiated. So at 0 degree, current equal to 0. When I increase the temperature to T degree centigrade, current flows. Current flow increases. Also, we have discussed resistance is inversely proportional to current. When current increases, what is the meaning? Resistance decreases. So in an insulator, when I increase temperature, resistance decreases. Resistance decreases with increase in temperature in case of an insulator. Now, we will come to the case of conductor. What happens in conductor? Say copper conductor. The electron in the last orbit, valence electron, will come out of the atom as free electron. There will be free electrons. Now when I connect it to an battery, I am applying a voltage between these two. So the free electrons will be attracted and there will be flow of electrons from the negative plate to positive plate. There will be even at 0 degree, there will be small amount of resistance. So when the temperature is 0 degree, there will be small amount of resistance, which I denote it as R0. Resistance at 0 degree temperature. That is the initial resistance at 0 degree. What is the cause for this resistance? Opposition offered by stationary atoms here. Now the atoms becomes ions, right? Positive ions, and it gives opposition to the flow of electrons. When electrons moves from the negative to positive plate, it will collide with the stationary atoms. In that way, the stationary atoms gives hindrance to the flow of electrons, and that gives rise to this resistance. Clear? Now I am increasing the temperature. Now I am increasing the temperature to T degree centigrade. Already there are free electrons. When I increase the temperature, what happens is the atoms or the ions start to oscillate. It will start to vibrate. It will move up and down. The atom will move up and down. It will start to vibrate. It gets extra energy. So it gets motivated and it will start to vibrate. It will start to oscillate. So when the atom starts to oscillate, when the electrons moves from negative plate to positive plate, number of collisions increases. Possibility for the collision increases. When it is stationary, through these gaps electron will pass through. And when it starts vibrating, when it starts oscillating, because of that thermal energy which I am giving, collision increases. When collision increases, when the number of collisions increases, the electrons reaching the other end decreases. The number of electrons reaching the other end in unit time decreases. That means there will be decrease in current. If there is decrease in current it means resistance is increasing. So in a conductor, when I increase temperature, resistance will also increase. In an insulator, when I increase temperature, resistance decreases. Clear? Now we need some formulas to calculate resistance at different temperatures. We shall see all the formulas which will be helpful for calculating resistance. Along the x-axis I am denoting temperature, along the y-axis I am denoting resistance. As I told you earlier, at 0 degree also there will be certain amount of resistance which I denote it as R0, resistance at 0 degree. When I increase the temperature to T, when I increase the temperature to T degree centigrade, the resistance will also increase. As I told, in conductor, the resistance increases with temperature. So resistance increases from R0 to the resistance at this point, say RT. Okay. So there is an increase in resistance from R0 to RT when the temperature is increased from 0 to T. Now listen very carefully. This increase in resistance depends upon two quantities. This increase in amount of increase in resistance depends upon two quantities. One, it depends upon the initial value of resistance. Two, it depends upon temperature, increase in temperature. So the increase in resistance depends upon two quantities, one initial value of resistance and another thing, the increase in temperature. So this increase in resistance, that is RT minus R0, is proportional to the initial value of resistance, that is resistance at 0 degree R0, and the increase in temperature T minus 0, that is T. Now we want to make it as an equation, RT minus R0. If I want to make it as an equation, what should be done? Yes, add an proportionality constant. The proportionality constant which I am adding is alpha 0. Alpha 0 R0 into T, where alpha 0 denotes the temperature coefficient of resistance. Resistance at initial temperature. Initial temperature is 0 degree. Alpha 0 denotes the proportionality constant. Alpha 0 is the temperature coefficient of resistance at 0 degree. Clear? So RT minus R0, the increase in resistance directly proportional to initial resistance as well as increase in temperature. Proportionality constant is temperature coefficient of resistance at initial temperature, that means 0 degree. So alpha 0. And this formula can be used for calculating resistance at any temperature if you know the resistance at 0 degree. So if I want equation for RT, what should be done? This R0 should be taken to other side. Here it is minus R0. When it goes to right hand side, it will become plus R0. So it will become plus R0, plus alpha 0 R0 T. So RT equal to R0 can be taken outside. So 1 plus alpha 0 into T. So record this in your memory. The increase in resistance directly proportional to initial value of resistance and increase in temperature. In this case T minus 0, so T. And the proportionality constant is temperature coefficient of resistance at initial temperature. Here initial temperature is 0, so alpha 0. So we can find the resistance at any temperature T knowing the initial resistance at 0 degree using this formula. RT equal to R0 into 1 plus alpha 0 into T. Understood? Shall I rub it? Yeah. Now I am going to ask a question. Once again, I am going to increase the temperature from T to T1. Now the temperature is T1 degree centigrade and the corresponding resistance, say R1. Temperature is T1, corresponding resistance is R1. Can you tell me an equation to calculate the resistance at T1 degree, knowing the resistance at 0 degree? The increase in resistance. This is the increase in resistance. What is that? R1 minus R0. So R1 minus R0 is equal to temperature coefficient of resistance at 0 degree, initial temperature 0 degree, into initial value of resistance into change in temperature T1 minus 0. So T. So R1 equal to R0, we can take it to other side. So it will become plus R0. So R1 equal to, both terms contains R0 which can be taken out as common. So 1 plus alpha 0 T1. Sorry. Temperature is T1 minus 0, so T1. So resistance at any temperature T1 can be calculated using this formula. So resistance at temperature T1 can be calculated using the formula R0 into 1 plus alpha 0 into T1. Okay. Now I am increasing the temperature to another value T2 and the corresponding resistance is R2. So the increase in resistance is now R2 minus R0. Can you tell me similar equation to find R2? So increase in resistance R2 minus R0 is equal to temperature coefficient of resistance at initial temperature 0 into resistance at initial temperature 0 into rise in temperature T2 minus 0, so T2. So similarly we can write R2 equal to R0 plus alpha 0 R0 T2. So R2 equal to, if you take R0 common, 1 plus alpha 0 T2. So if you want to find the resistance at different temperature R2, we can find it. So R2 is equal to R0 into 1 plus alpha 0 T2. Shall I run? Okay. So if you know the resistance at 0 degree, you can calculate the resistance at any given temperature using the same concept. Now I am asking another question. I don't know the resistance at 0 degree. I know the resistance at T1 degree centigrade and this is R1. I want to find the resistance at T2 degree centigrade and it is R2. Resistance at 0 degree is not known. How will you find the resistance at temperature T2? Can you find? So what is the increase in resistance in our specific problem? Initial resistance, which we know is resistance at T1 degree centigrade, that is R1. Now temperature is increased to T2 and the resistance is R2. So increase in resistance is R2 minus R1, correct? Resistance is increased from R1 to R2. So change in resistance is R2 minus R1. Now apply the same concept which we used earlier. So R2 minus R1 is the change in resistance, that is equal to temperature coefficient of resistance at initial temperature. What is the initial temperature? T1. So temperature coefficient at temperature T1, I am denoting it as alpha 1. Temperature coefficient at 0 degree, alpha 0. Temperature of coefficient at T1 is denoted as alpha 1. So alpha 1 denotes temperature coefficient at temperature T1. Now T1 is the initial temperature into initial resistance. Now R1 is the initial resistance into rise in temperature. Rise in temperature is from T1 to T2. So T2 minus T1. We have applied the same concept. So from here, if you want R2, formula to calculate R2, take this to other side. Minus R1 became plus R1. R1 plus alpha 1 R1 T2 minus T1. So both terms contains R1, take it common. So 1 plus alpha 1 into T2 minus T1. So this is also an important formula to calculate resistance at temperature T2, knowing the resistance at temperature T1 and temperature coefficient at T1 alpha 1. Clear? R2 equal to R1 into 1 plus alpha 1 into T2 minus T1, where alpha 1 is the temperature coefficient of resistance at temperature T1. But in some practical cases, the temperature coefficient at T1 will not be known. Alpha 1 will remain unknown. You will be knowing only alpha 0. Alpha 0 is known. Can you use this formula directly? Because alpha 1 is unknown. We know only alpha 0. Temperature coefficient of resistance at 0 degree is known. Resistance at temperature T1 is known. We are asked to find the resistance at temperature T2. We cannot use this formula unless we know the value for alpha 1. But we know only alpha 0. So we need a strategy to calculate alpha 1. Right? How to calculate alpha 1? So let us derive a formula to calculate alpha 1. This is what we need. We need in terms of alpha 0. So from here, write alpha 1. Alpha 1 equal to, the entire thing goes to denominator of this one. So R2 minus R1 divided by, this goes to denominator. So R1 into T2 minus T1. We know only alpha 0. Alpha 1 is needed. So R1 and R2 substitute in terms of alpha 0. We have equations. So what is R2? R0 into 1 plus alpha 0 T2. Then minus R1. What is R1 in terms of alpha 0? R0 into 1 plus alpha 0 T1 divided by R1. This should be also substituted in terms of alpha 0. R0 into 1 plus alpha 0 T1 into T2 minus T1. Clear? Now we have to simplify this. In order to simplify this, take this R0 inside. So 1 into R0, R0 plus second term into R0. So R0 alpha 0 T2 minus R0 into 1. So minus R0, then minus R0 into this term. Minus R0 alpha 0 T1 divided by R0 into 1 plus alpha 0 T1 into T2 minus T1. Now, first term is R0. Third term is minus R0. So, these two will cancel. R0 minus R0 will become 0. Right? And second term and the fourth term contains R0. So, we can take that R0 as constant. So, if I take R0 as constant, we will be having R0, alpha 0 is also there in both terms. So we can take R0 and alpha 0 constant. So we will be having T2 minus T1 divided by R0 into 1 plus alpha 0 T1 into T2 minus T1. So this T2 minus T1 in the numerator and denominator can be cancelled. This R0 presence in numerator and denominator, it gets cancelled. So what is the thing? Alpha 0 divided by 1 plus alpha 0 into T. So if you know alpha 0, we can calculate alpha 1 at any temperature T. So what are the relationships which we have studied? If you know the resistance at 0 degree, we can calculate resistance at any value using the formula RT equal to R0 into 1 plus alpha 0 into T. If you know resistance at any temperature T1, and if you are asked to calculate resistance at temperature T2, we have formula R2 equal to R1 into 1 plus alpha 1 into T2 minus T1. Then if alpha 1 is not known, we can calculate alpha 1 using the formula which we have derived. Clear? Alpha 0 divided by 1 plus alpha 0 into temperature T1. So in that way, we can calculate the resistance at any different temperature. That will be practically useful. Then before winding up the session, I want to recollect something which we have studied in the first class. In the first class we have studied about voltage and current. What is voltage? What is the formula to calculate voltage? Just tell me the formula. Work done in charging a particle. So work done by charge. Voltage equal to work done by charge. And what about current? Rate of flow of charge. So charge divided by time is current. This is what we have studied in our first lecture. Next, before winding up, I am going to derive formulas for calculating electrical power and electrical energy. So what is power? Power is the rate of doing work in an electric circuit. Rate of doing work means work done divided by time. Work done divided by time. So we need formula for electric power using electrical quantities voltage and current. This is physical quantities work done and time. While studying about electricity, we need the formula to calculate power in terms of electrical quantities voltage and current. So using this equation, if you want work done, how will you find work done? Take this to the other side. W equal to V into Q. So instead of W, substitute V into Q. Right? From the equation for voltage, work done by charge. So work done equal to voltage into charge. So voltage into charge. What is this? Q by T? Q by T, current. So electrical power is the product of voltage and current. This is one formula. Then based on Ohm's law, what is the equation for voltage? V equal to, V is proportional to current, proportionality constant R. So V equal to R into I. Substitute that in the equation for power. So V into I. So instead of V, substitute R into I. So I square into R. I into I square into R is the equation for power. So either V into I or I square into R. What is the unit for power? Work done unit is joules. Time unit is second. Joules per second. Right? Unit is joules per second. This joules per second is also called watts, denoted as capital W. So unit for electric power is watts. Next, what is energy? Total work done in the electric circuit is energy. What is power? Work done by time. Energy is work done. So if I want energy in terms of power, work done equal to power into time, right? So power into time is work done. So what is the equation for power? One equation is V into I. So V into I into T. Other equation I square R. So another equation for energy is I square into R into T. So now what is the unit for energy? What is the unit for power? Watts. Unit for power is watts. Unit for time? Second. So unit for energy is watt second. But practically, when measuring energy consumed in our houses, we will be using power, or we will be measuring power in terms of kilowatt, and we will be measuring time not in seconds but in hours. So practical unit for measuring energy is kilowatt hour. Power measured in kilowatt, time measured in hour, kilowatt hour. So while measuring energy in our houses, we used to say, this month I have consumed 50 units of energy. What is that unit? Kilowatt hour. 50 kilowatt hour is the energy consumed, means we used to say 50 units of energy, right? So unit for energy is kilowatt hour. It is normally called unit. So that's all for today's class. So in the next lecture, we will solve few practical oriented problems applying the concepts which we have studied in the last two lectures and this one. Okay, we will see in next class. Thank you.